recording here. Okay. So you have planning and design in the network part. Okay. In the network part, then you have your physical network requirement. So from which page you are looking at physical network requirement, right?
Yeah, physical network requirement.
Let me see that.
Installing, configuring and setup.
Advanced features. Okay.
Network configuration.
So here network design consideration. I am talking about network design consideration. Okay. So you open planning and designing. Okay.
Okay.
So you open the network design consideration. Okay. So we will be using the switch type here. What will be the switch type? Okay. So is it for load balancing? Okay, you just see it here after this requirement. Okay. This is where switch type. Okay. You VDS for centralized management, LACP and network IOC control. Okay. Then you have uplink design. Okay. So uplink design, how your physical adapters are separated from different top of the rack. So you see here, these are the two top of the rack. You are going through a different TOR, top of the rack, for switch redundancy. Okay. So if one switch fails, then the other will take over. Okay. Then you have traffic segmentation. Okay. So you are separating all the traffic, okay, from the host. See, this is VM traffic. Okay. Then there will be vMotion traffic, storage. Okay. Then for management. Okay. So you are separating the complete VM traffic. Okay, via VLAN or dedicated NICs, you are separating it. Then you have NIOC. Okay. NIOC, you will limit the bandwidth share. You will limit the traffic type to prevent the congestion. So that is where you will use NIOC. Okay. Then you will have dedicated vMotion network. vMotion network, so that you will enable jumbo frames. This is how it looks like in the realistic picture. Okay. So that is the network consideration. Okay. So now you see it from the physical layer, hard grade. Okay. So you have NIC supporting features, checksum, all that you will be uploading that. So you have here two VM traffic. Okay. So let me open up this design. Okay. So you have scalability, availability and scalability planning. Okay. So how you will design a cluster, HA cluster. So let's say I will give you the question here, how you will design a cluster. Okay. In this context, okay, let's say a financial service company requires high availability for their core application. Okay. They need to ensure that if a physical host fails, okay, then VM should restart quickly without data interruption. So that is the context. Now you need to design a solution for this financial services company. Okay. How you will design? I will explain you. Okay. This one I will explain you. Okay. So first you will design a cluster sizing, okay? Four node cluster you will deploy, okay? N plus 1 redundancy. N plus 1 is 3 hosted needed for workload and 1 for failure, okay? So a 4 node cluster is deployed to provide N plus 1 redundancy. Means N is here 3, at least you need 3 plus 1, okay? 1 you added, okay? That is for failover, okay? Then you will do a admission control, okay? So that the cluster resource percentage set at 25% to guarantee failure capacity. Okay. So you will set a 25% cluster resource to guarantee a failover capacity. Then you will have a heartbeat data store. Two shared data stores are configured for heartbeat to detect host isolation accurately. Okay, you will be accurately detecting the host isolation. 2 data stores. So you will configure 2 data stores. Okay. Then you will have VM components. Okay. VM component protection is enabled to automatically restart VMs in case of all paths are down or permanent device loss, storage failure. Okay. So this is how you will configure it. Okay. Once this fails, it will be failed over to a different host. Okay. So then we will have one more example. Okay. So I will give you the scenario. So an enterprise IT wants to ensure that vCenter itself never fails. Okay. It's never experienced downtime, as losing management access during an outage would be catastrophic. Okay. So during a DR, this should not go anyways. Okay. If this goes means completely it will be a disaster. So how you will design the vCenter HA?
Okay. Then we can deploy 2 vCenter VM in different hosts.
Okay.
And we can create the cluster and all things in both vCenter. We can add and can synchronize.
What is the main component here? What is the main component?
vCenter server?
No. See, you need to have 1 millisecond, even a single millisecond. The requirement is like the customer doesn't want to have a single millisecond. Okay. So you need to have a synchronous replication for that. First thing is you need to have a synchronous replication. If there is no synchronous replication, you cannot copy like that. Okay. So if they don't have it, what you will do, you will have a fault tolerance. Okay. You need to have a dedicated 10 gig link, okay, and low latency. Okay. So first you need to consider it exclusively. It should be exclusively for FT logging. This should be very fast. Okay. So this you should ask the question how the FT is going to log in here, so that the 2 VMs will be in perfect sync. Okay. So let's say if you have more, this is 300 kilometers distance apart from this. One is away from 300 kilometer distance. Then you have to ensure that your data is replicated within 1 millisecond. Okay, that you have to ensure. Without that, that is not possible. So your link, it will depend on the link. Okay, so this is where you should ask the question, what is the dedicated link you have for FT logging. Okay, then you will have a hardware requirement. Okay, so they should be having the same CPU family. If they are different, you cannot have it. Okay, so then you need to limit, the VM is restricted to 8 vCPU or less. If it is more than 8 vCPU, it will not work. Okay, these are all the limitations of the fault tolerance. Okay, so this is a cloud hosting provider. Okay, they are experiencing high variable workloads. Okay, during the day, CPU usage spike on certain host. Okay, only on certain host it will spike, while at night storage bottle IO will occur on specific data store, not on all data store. Okay, now you design the solution. How you will design it?
You can manage the load by using the DRS feature. Then we can
So I will let you know. Okay, so here in this scenario, okay, so what you are going to do, first you will implement the compute DRS. Okay, so once you enable the DRS, okay, migration threshold is tuned based on workload stability to automatically migrate VMs. Okay, vMotion to balance CPU and memory workloads across all the cluster. Means there is no DRS cluster enabled. Okay, so they don't have DRS enabled there. Then you will enable storage DRS. Okay, a data store cluster is created. Okay, storage data DRS is enabled with IO metric. So you will put a IO metric active and the latency threshold should be set to 15 milliseconds. Okay, if there is a latency between greater than 15 milliseconds, okay, storage DRS should proactively migrate VMDK files to less busy data store. Okay, if it is greater than 15 milliseconds, you are moving that data store automatically. Okay, that should be your design. Okay.